sample that we are using are already healthy people.
Yeah, this is
Even
very
healthy
good
people.
interpretation that the sample which we are drawing is from the healthy people. So sample selection was well defined. So I can call that sample selection. This is a very important thing. Sample selection was done in a very meaningful, structured way so that the relevant information can be generated. So if you have a wrong sample for the purpose, then probably you may not be able to derive or explore the relevant information. So good. What else? Anything else which you would have found? Okay, so this makes sense if I say that these three are the relevant points which we have in the case let. And in addition to that, if you look at the questions, there are some questions also. So as you see here, there are some questions. So question also says that develop a model to relate weight with age and height of the healthy people. And we have taken the sample of healthy people. And then the next question talks about the prediction. If some parameters are given about a particular student having certain height and certain age, then it is asked that what is the healthy weight which that person can have. And we'll expand this idea. I will not give one number, rather we would like to give a range. We'll see to it how we can estimate the not just value but the range, and that too the range should be meaningful, having some corrective thing also. It's not that just because we want to have a range we are having a range, rather the range on the basis of certain scientific logic. So we'll see to it as we gradually proceed with the caselet. So first of all, I'll show you the templates. Have you gone through the templates? So as you are
Yes,
finding,
sir.
there are, yeah, you have gone through the templates. So if you look at the template, first template is about descriptive statistics. Second template is about the regression results. And third template, as you are seeing here, it is about the how to discuss the regression analysis. So all these three things we'll be using. But before we start discussing about the output or we do the processing, let me take you to the importance of descriptives. Look at this, descriptives. You have had some sessions of statistics class. I think Anugamini is teaching you.
Yes, sir.
So you must have got some idea about descriptive statistics and inferential statistics. Yes, no?
Yes, sir.
So if I try to relate things in a general way with this case, so what happened whenever we want to study anything, the thing which we want to study, we can call it variable. I'll give you a brief idea about descriptive. So whatever we want to study, that can be called as variable. And in statistics or for decision making, always variables are always studied on certain lot. Lot must be having some lot size. Uh, And when we study any variable on a lot, we generate values. And if we arrange the values in either ascending or descending order, what happens? This can be termed as distribution. Now, if I just want to know this variable, then I need to study this distribution. And when I say we need to study distribution, then any distribution can be studied with the help of these three parameters, which is very popular in statistics. We call it measure of central tendency. Means what is the representative value of that particular variable studied on a particular lot. So what is the representative value that we call measure of central tendency? Then we have got measure of dispersion. Here we study what is the variability of values of the variable on a particular lot. And then we have got third descriptive, which is known as measure of shape, where we study if we have distributed the values in ascending or descending order, and on the y-axis, if we are having the frequency, if we are having the frequency on y-axis, on the x-axis we are having the values, then the shape comes. Then shape may be symmetrical about the mean. Usually you come across some bell shape. So what happened? We say that this is the this bell curve is symmetrical about, and this we call as mean. So whether the distribution is symmetrical about the mean, what is the pickedness, what is the height at the point of mean, all these things are studied under measure of shape. So what happened whenever we have to study any variable, we would like to know these three things about the distribution of that particular variable. Measure of central tendency, usually there are many measures like mean, median, mode, all geometric mean, all come under measure of central tendency, but usually we use arithmetic mean to represent or to use the important measure of central tendency. Similarly, for measure of dispersion, we take standard deviation, which is also known as sigma. And measure of shape, sometimes we don't use it unless until it is very essentially required. Otherwise, we can, but normally we skip it. Then we are finding one more thing which is important in this context of descriptive. As long as if we have one variable, these three things work. But by the time we have got two variables, let's say x1 and x2, then we would like to find out third descriptive, which we call measure of relationship. Measure of relationship can be studied with the help of two things. First is correlation. Correlation is degree of association. And second measure of relationship is regression. This is what we are studying here right now. So I hope the point is clear. Still, when we say regression, by the time we have migrated from these three to measure of relationship, we are venturing or we are moving from descriptive statistics to inferential statistics. So measure of relationship starts, by the time we start talking about measure of relationship, whether correlation or regression, we start venturing into inferential statistics. If you want me to give a brief idea about inferential, when we have, let's say, population, let's say of capital N number, and we study a small sample, let's say of sample size N, and we study this, and whatever results we get out of here, with the help of studying the sample, we try to infer results about the population. So this exercise can be termed as inferential statistics. So as I was saying, that as we move from measure of central tendency, measure of dispersion, measure of shape to measure of relationship, we start exploring not only descriptive statistics but inferential statistics as well. Now the question is why at all it is important. So
Sir, I had a question, if
yeah,
I may.
yeah.
Sir, in this inferential statistics, I was going through the video that you sent, sir, yesterday. Sir,
Yes.
when you say that we infer certain values or sample, what are the kind of inferences? Are it still mean, median, mode, or what are the kind of inferences we're trying to make?
Suppose very simple example, we are studying right now weight. Huh? Just concentrate on one variable weight. Huh? And I want to say, let's say my claim is that MBA students have this year become very, we have got very obese batch. Means people are having more weight than what they usually have. Hello? So this batch has got more weight than usually students have. In that case, what happened? I have a claim about the batch, but I'm not studying the whole batch. Let's say 250 students, 250 odd students. I have studied only 15 or 20 students for that matter. So I am looking at the mean weight of, obviously I'm studying the mean, but my purpose is to study the weight. Weight is the variable. To study the weight variable, I'm using mean as a tool. And what I found that mean weight of the sample is, let's say, 55 kg. And the my claim about the batch weight is, let's say, 65 kg. So now what I'm trying to do, I'm trying to understand by studying the mean weight of the sample of 55 kg to infer or to support or reject the my claim about the mean weight about the whole class. So when I say inference, inference is not limited to, though I have taken the example of mean to explain to you concept, I'm using sample to derive the or interpret the things maybe the variability, things may be mean, things may be anything about the population. So when I'm using sample to derive anything or infer anything about the population, I call this as inferential statistics.
I got your point, sir. Thank you. I
So
got
it
it.
is not limited to mean, don't confuse with this, but mean is something which is quite frequently used. So this type of conclusion is also pretty obvious, but the domain is pretty wide. It's not limited to mean, right? I'm open to any other question. So let me continue with what I was talking. I was talking about descriptive. So what happened? Though we will be having many analysis, we are just starting with regression, we'll have forecasting, we'll have volatility models and whatnot. It is always very strongly recommended that whenever you are doing any statistical analysis, anything which you would like to do with the data, it is always great to start with descriptive. Descriptive is putting the things in a certain way so that you can have a fair amount of idea that what are the possible things which we can think out of the given data set which is available to us. So descriptive should be the beginning of any advanced analysis. It is like starting, I mean, when we meet somebody, we start with what is your name, what do you do, where do you work, where do you stay. So descriptive provides that type of relevant information. So I'll start today also, but for all the future studies, whenever you are doing any data study, anything which is based on data, always start with descriptive so that you have an initial introduction with the data. And later on also, as you will come across as we proceed with the course, that whenever we do anything advanced, we come back to the descriptive to, you could say, partially corroborate what we have found. At times we take a lot of input from the descriptive to support or to reject whatever we would have found with the help of our advanced analysis. So what I'm saying that descriptive is very good thing to start with for any advanced data analysis, and it is always very helpful to have descriptive ready. So today also, as I'm starting this interpretation of this caselet, I'll start with the descriptive. If you look at this, I have developed templates and I'll try to give you a template for every type of analysis so that it becomes very easy for you to replicate. Means suppose you want to do any other study on any other topic, you have a ready-made template available where you have to just restructure it, adjust it according to your data and fill the template and your analysis is ready. And the second job will be to interpret, that will be learning gradually. So the template. So this is one suggestive template. I'm not saying this is the only possible template about descriptive. There can be many, but my experience of a few years says that this is the best way to present the descriptive statistics of any data set. If you look at what I have given to you, why is, whenever we are doing any study, there is always, if you remember, we have discussed this earlier also. Normally, what happened that we have got some variable which we would like to know the impact, and there are some variable the impact of. So what we are doing, we are trying to study the impact of X on Y. So the variable on which we are studying the impact is known as dependent variable, and the variable of which the impact of the variable or the impact of which we are studying can be termed as independent variable. There are different names also we'll be using as and when we have a necessity. So independent variable. So we look at this template. I'm having one y, but in template I could have removed this. I could have straight away put here. In my case, I could have called it weight, and another variable I have got. I could have called this height, and then I have got age. That's it. And intentionally, I'm keeping things simple here. Suppose I have got more than two independent variable, I could have one more column here next to age, and I would have written that. So it's a very general format. Here also I can put it weight. Here, as you look at the format, In the template, we are not differentiating which is the independent variable and which is the dependent variable. We are just using it as it is. We need to understand descriptive as such normally do not differentiate between independent or dependent variable in regression analysis. It talks about the variables. So as you are finding it here, in this part of the descriptive, we are talking about regression analysis. If you would have paid attention, I was talking about measure of relationship, and one of the important measure of relationship is correlation. I repeat what correlationship does. Correlationship talks about degree of association. On the other hand, regression talks, what we are studying right now, regression talks about exact relationship between X and Y. And suppose I say that correlation, then only I'll be finding out degree of association. Coming back to this, so this portion talks about measure of association. And then as you are finding that we are using measure of central tendency, mean, arithmetic mean, and this is measure of dispersion, variability of the values of variables studied on a particular lot. So we'll be using this measure of dispersion, which we call standard deviation. And VIF will make use of it as we move to table 2. We'll come back because VIF is again optional, whether you want to put it here or you want to put it at the second table, that depends. So this option is available at both the places. Anything so far? Are we are good to go?
Yes, sir.
No questions?
Yes.
Feel free in asking. I have no problem in answering you. Just unmute and say, while I'm speaking, you can disturb me. I have no issues. So,
Sir, can you please elaborate more a degree of correlation?
Degree of?
Correlation.
I'll give you one example. Let's say there are two friends. So I just want to know if one is absent, will other fellow be absent or not? So what is happening? It is not a mathematical relationship. Rather, I'm looking at what is the possibility. So if they are good friends, you will normally find that both of them would have bunked together. So if one is absent, then in good likelihood, if they are good friends, then second fellow will also be absent. So this is known as degree of association. But suppose I have developed a model that I'll say that one person is absent, how it is related with the other fellow's absence in the class. So when I'm finding out one mathematical association, there we can with certainty say that if he is absent, then this is the number of, this is the association. Like when I say that absence of Mr. X is equal to beta 0 some value, beta 1, and absence of Mr. Y. So here what I'm saying, I'm trying to find out the exact association. But when I'm only interested in knowing the degree of association, so degree will not give me the exact mathematical description. Rather, it will give me only the idea, degree, whether they are good friend, and the degree of association can be other way around. Means if one goes up, other goes down. So when we say degree of association, that is measured usually with the help of Karl Pearson correlation coefficient, which is having the values between +1, -1 to +1. But in regression, there is no such absolute values which can be used. So that is the on the surface of it, the difference between correlation, which only talks about the degree. On the other hand, regression, which gives you the exact mathematical association between variable. So that is the possible explanation of this issue. What is degree and what is the exact association between variables? Is it okay?
Yes, sir, got it.
If you're not clear, I can give you more example. But this is practically the degree of association and exact relationship. Yeah, any other question? So coming back to correlation, so I again reiterate, it is great to start with descriptive statistics whenever you are doing any type of analysis. So I'll straight away go to eViews. I believe all of you have got eViews as well as Stata with you. I'll show to you how to start with the eViews and then I'll take you to Stata. And if you remember, I have just opened the eViews, and right now I'm going to enter the data. So first of all, I have to make a worksheet. Before I make the worksheet, look at the data. This is the data set. I guess all of you have got access to Excel file. Yes?
Yes, sir.
So this is the Excel file which I am using for this caselet. If you look at, then what we are finding, there are 10 observations. The number of observations become important when we use it, when we use eViews. So here, as I have told you last time, we'll go for unstructured, undated. Number of observations are 10 and just okay. So you have got a worksheet which will be taking only 10 observations. To enter the data in the system, you go for quick empty group. This is what we have done last time. I have to click it. And as I've told you, just because I want to enter the fields also, name of the field, so I have to just click it and take the cursor one step ahead. I'll go back to my Excel sheet. And essence, CL number is not important. Only this much information is relevant for me. I'll Control C, copy. I'll go for Control V, paste. And I need not do anything, just delete the group. And as you would have deleted the group, what you are finding that in the very beginning, when you have made one worksheet, C and reset are by default present there. Reset is residual, we'll understand things gradually. So these are C and reset are by default present. And these three new variables we have made, I can show to you, I have selected three variables, go for right click, open as group, and you have got the same data available to you. So this is the one of the ways by which we can easily enter the data in eViews. And next thing is we would like to fill this sheet. So let's start with the mean and SD, and then we'll move to correlation using eViews. So what I need to do, I need to open it as a group, and then I can go to view, and within view you are finding descriptive statistics, individual sample. So I will, you can make a note of it because later on you will forget it every time you might have to open this video. So I'll suggest that you can note it like something like this so that it becomes handy for you. You can note it like open as group, and then you can say you go for view, and within view you can say descriptive statistics, and then you can say individual observations. And as this type of path you can suggestive again. This is my style. You can have your own style. So I'll go to view descriptive individual samples, and as I have clicked it, I've got these information. I've got, if you pay attention, I was talking about measure of shape. So these things are available: kurtosis and skewness. Skewness measure the symmetry about the mean. Kurtosis measure the pickedness. I'm not using that much information as of now. I'll be able to use them as and when I need them later on. Right now, my interest is only for mean, median, mean, as you're finding mean for all the three. And then I have got standard deviation. So I'll use only these information. So I can, copy it also. I can come back. So let me fill the mean of age 71, 166. So if I have to fill this 71, 166. And if you would have gone through the caselet, units were also given. Weight is in kgs, height is in centimeters, and age is average age is 43.20. So I'll write down 43.20. Sorry. This is 71. This is 166, and then it is 43.20. And then I'll just quickly look at the values of standard deviation. Standard deviation of weight is 9.94. I'll round it off to 2 decimal point, 9.94. Height SD is, I guess all of you are following me, 9.95, 9.95. And then for age, the standard deviation is 10.55, 10.55. Now my question is, Suppose I say that the weight standard deviation is 9.94. What does it signify? Question to you. When I say weight is having standard deviation of 9.95 kgs, remember mean SD all the time take the normal unit of the variable. So mean weight is 71 kgs, standard deviation is 9.94 kgs. Now my question is, what does it signify when I say the standard deviation of weight is 9.94? Any one of you?
The maximum
Yeah,
uh,
please.
from the mean, the maximum upside or the below side the value can go. That is mean plus standard deviation or mean minus standard deviation is the
A
mean.
follow-up question. Suppose I say that the standard deviation of another lot of weight variable is, let's say, 12.30. So now how would you like to compare 9.95 and 12.30?
So the first, the initial, the answer we got has more spread. The answer, the question that you give has less
Second
spread.
has
So the
got more variability as compared to the first. Is that the right answer?
second is less variability.
No,
No,
no. Higher
you
the
said
standard
mean.
deviation value means more the variability.
Okay, yeah, yeah,
Okay, other way around. If
yes,
standard
sir.
deviation is more, it means variability is high. Understanding of descriptive is very important. You know, it is like knowing the variable. When you have the descriptive with you and you understand the descriptive well, it means you know the variable well before you do any advanced analysis. So descriptive is not that need. So okay, understood. I guess you have understood. Higher the value of SD means more the variability,
More variable. Yes, sir.
more the variation in the data. So coming back to this, yeah. So we have partly filled this. Now we have to quickly go through the correlation matrix. So I'll go back. Again, I'll continue with my group. Those who have missed, again, I'll show to them. I have to just select age, height, weight, selected, open as group, and this is here. And in this, I have gone for descriptive individual sample. I had that detail. Right now, what I'm doing, I just want correlation. So look at here again. I've opened the three variable which I'm interested in for my descriptive as a group. View, I have gone into view, and then this covariance analysis. I need to click it, then you will find this dialog box will come in eViews. As started, I've got different story. I'll come to it. You just go for correlation, and I'll suggest that you select these two also. You have to remember, I'll explain what I'm doing. Let result come, I'll explain to you. All of you are with me?
Yes, sir.
Yes, sir.
So I'll again show, though it will be available to you as a recorded video, but covariance, then I have deselected, selected correlation, T statistics and probability. Now I'll go for OK, I have got something like this. Look at here. So now this is correlation matrix, age, height and age, weight and age. You know, these are kept blank. Above the diagonal kept blank because it will be mirror replica of whatever is below the diagonal values. So there's no point. So no software will give you the values. So only these values are there. So association between age and weight, height and height is again one, weight and weight is again one. So diagonal values will remain always one. So practically these three values are important to us. Now we need to interpret. This is clear to you. I'll use these three data. Let me start with the association. Let me use this first. The correlation between height and age. So whether it was age and height here, it would have been the same value. So now there are three values. If you remember, as we have, please remember, we have, as we have gone for eViews, we opted for three things. So now I'm talking about the interpretation of correlation. So to interpret results of correlation, there will be three things. The first is value. Correlation, Carl Pearson correlation coefficient, as I have told you that this value may be from -1 to +1. So this is the first thing which we report or which we use. Second thing is T statistics. and third is p-value. Just give me a brief idea. Have you understood anything about t-statistics, normal distribution, or anything? Significance testing, hypothesis testing, anything you have covered so far in your stat class?
No, sir.
Yes, no?
No, sir.
No, sir.
No, sir.
No issues, no issues. I'll explain to you whatever I require. So what happened, look at here, I'm just drawing one distribution. We call it sampling distribution. Ignore the nomenclature and all, you just understand the concept. This is a distribution where practically here it is mean. And what happened that there are two extremes. We call it two-tail situation. And I'm making some so that it represents the rejection event. And you know what we are doing? We are having some hypothesis. We call it null hypothesis. Null hypothesis is of two types. No difference and or of no association. So we'll be using this, we'll be using both. So right now I'm using the null of no association, means my claim will be, I have to have a claim before I accept or reject the claim. So in the correlation analysis, the claim is this Karl Pearson correlation coefficient, this R is 0. So in a way I'm saying that there is no association, and this is what my statement is also. Same thing. What I'm saying, null can be either no association or no difference. Only two types of null are there across the board. I repeat, across the board there will be only two types of null. The basic hypothesis which we accept or reject, and we have a supportive hypothesis which we call alternate hypothesis, which we show with the help of H1, and we'll have exactly opposite of it. We'll say that R is not equal to 0. So this is pair of hypothesis which we always use in any type of analysis. We call this testing of hypothesis, or we call it testing of significance. Both the names are used interchangeably. And this is done because what we are saying that we are using a sample data to infer the result about the population. So just because we are having sample information which can be used for population, so every time whenever we derive any information from sample, we need to go for testing of hypothesis or testing of significance, so that we are assured that whatever result we are deriving, that is appropriate or not. Unless until you have done testing of significance for a sample data, it is not good to use that information for population. So anything studied from sample and you want to use it for population, you are supposed to do testing of hypothesis before we want to use the sample information for population. So same thing we are doing. We have got a population sample here of 10 healthy people, and we would like to study the association between them, degree of association in the form of correlation. So we have to test the testing of significance. When we want to go for testing of significance, this is the pair of hypothesis which we have to start with, and then we'll go for testing of hypothesis. If up to now you are understanding whatever I have explained, what I have not explained, don't worry for that. Whatever I have explained, if that much is clear, I can proceed. You are free to react.
Hello, sir.
Yeah.
So you said about no association is when we are taking R is 0, like we are claiming that there is no association.
Okay.
What is no difference? You said
No
there are
difference, just wait. As we move to coefficient analysis, we'll use the null of no difference. Just wait for 10 more minutes. Let me move from table 1 to table 2. We'll use null of no difference. Right?
Yes, sir.
Please feel free to ask questions if you have any doubt. I repeat what I am saying right now. I'm saying whenever I'm using sample data for population, I need to go for testing of hypothesis. Testing of hypothesis is always done with the help of null hypothesis. Alternate is supportive to null. There are two types of null: null of no difference and null of no association. Right now, we are having a situation where we are trying to find out whether the association between two variables, let's say weight and height, is significant or not, or meaningful or not, or can be used for population or not. So I have to start with null hypothesis of no association, because I've got two types of hypothesis. So I'm using the other one, no association. And I'm right now going to test whether my null is going to be accepted or rejected. So that whatever value, if you look at what we have got in the, as we have run the EViews, we have got the value. This is the value. Look at minus 0.23. So if I round it off, minus 0.24. So let me put it this way. Right now I've got the value of R minus 2 minus 0.2 24. Just rounded off to 2 decimal points so far. So I've got the value of R, which is minus 0.24. Look at, first of all, the value of R should always be. I've found people commit mistake, especially when they start doing the analysis. If R value is more than or less than, I mean, it is less than -1 or more than +1, it means something somewhere is wrong. The value of R cannot be like that. So you would have either written it wrong, or you would have taken the wrong value, whatever. There is some mistake. So right now we are sure that the R value is 0.24, so which is between -1 +1. So it seems it is okay. But next is, I have to ensure whether this correlation coefficient between height and age is good enough to be used for further analysis or not, or is it good enough to be used for population. I need to test through testing of hypothesis. To test testing of hypothesis, this I'll not explain all the time. I'm explaining once for association, once I'll explain for difference, and then I'll quite often, straight away I'll start using the results, and I'll say whether the result is significant or not. So I'm investing that much time just for once. So what I'm saying that I will be testing this hypothesis. So to test this hypothesis, I'll be using some distribution. This is again a representative distribution, because distribution will be changing time to time, case to case, test to test. So right now I'm making use of T distribution. So I've got shape of T distribution. There could be other distributions. For example, just for your general awareness, you'll be using F distribution, chi-square distribution, many distributions we use. So they have got different ones. So the idea that when we go for testing of hypothesis or testing of significance, what exactly we are trying to do. So what happened to either accept or reject the null? I'll concentrate on null only. I'm repeatedly telling you, we'll concentrate only on null. Alternate is only there to support. So when I say I'm concentrating on null, so either I have to accept or reject the null. So to do that, I need to calculate the value of T, because this is the T distribution shape. So T value, there are two possibilities. T value, calculated T value may fall here, option 1, or it may fall here, option 2. And this, what I am saying, this is a distribution which is supposed to be 100%. I repeat, the area covered between this x-axis and this curve is supposed to be 100% or 1. And what we are saying that here it is 2.5%, and here this is 2.5%. And I'm saying that I'm using the confidence level of, which we are also calling in some other language, level of significance, as 5%, which we also show with the help of alpha. This is a barometer which we use for testing of significance. What is the barometer? Suppose that this is the claimed value. Right now, what is the claim value? That correlation coefficient is 0. This is the claimed value. Whatever we claim, that we assume that it is going at the mean level. And we have estimated one value which is 0.24. We will convert this 0.24 value, which is practically on the scale of x, to the scale of t, so that I can compare on the t distribution. So this x scale, if I draw one more curve, so one distribution, and distribution is practically, shape is not coming perfect, please ignore that thing. So scale is x, and I can convert this x to t scale. So here I am having the mean value x bar, but corresponding t value I'll be calculating. So here mean value is in our case, I can say that mean value is r is equal to 0. The claimed value we consider as mean value, but I have one more parallel scale on the t scale, one set of distribution on t scale. So t is 0. T will always be 0, irrespective of this claim here. And right now what I am drawing is two extremes. Now the possibilities. The R I have calculated. R will be converted from R or X variable to or X scale to T scale. I can do that, normally X minus X bar by sigma. I don't want to complicate. So what is happening? This is the variable, X variable, which is converted into Z variable. If you replace Z by T, and I have got, let's say, R, mean of R divided by sigma of R. So this is the transformation table. I can convert the scale of R to T. So don't go into that much complication. I like to keep things simple. The point here I'm trying to highlight is I will be calculating or converting the value of estimated R from the scale of X to the scale of T. And then I'll be, there are two options as I was talking about here. Either the value of, this is the all the possible value of R, all the possible value of R. So this distribution at two extremes have been separated. Here I'm saying 2.5%, and here I'm saying 2.5%. And if the calculated value may fall here or here, there are two options, option 1 or option 2. Because option 2 means anywhere from the both the rejection region, between these both the rejection region, anything can be second option. And if the value falls, whether the R value or corresponding to value falls here or here, so that is falling on the rejection region. Now you understand the difference. What happened? Difference between option 1 and 2. Now you try to understand, suppose I have got a value of R using a particular sample. I have calculated the corresponding value of T for a particular sample. Now there are two possibilities. Either the difference between claimed value and the estimated value will be only small. The difference between these two may be small and which can be ignored. So this is one interpretation, and we'll say that the difference between R and R claimed, in our case, if I say R value is minus 0.24 and claim value is R is equal to 0, can be ignored because the difference is small. This is one interpretation. In that case, I'll say that null of H naught R is equal to 0 should be accepted because the estimated value of R, though it is mathematically it is different, 0.24 minus 0.24 and R is equal to 0, mathematically they are different. But statistically on this distribution, the difference between these two is small, which can be ignored and we can accept the null hypothesis. But if I look at the option, this option, where the difference, the value, the estimated value of R or corresponding value of T, if it is falling in the rejection region, what is the interpretation? that the difference between claimed value and estimated value, R and R claimed, is minus 2.4 and R is equal to 0, is big enough. If the estimated value, so I do not know when I have got a sample and I have calculated their correlation coefficient value 0.24, I do not know whether the corresponding t value is going to fall in the acceptance region or a rejection region. I need to calculate, and that calculated value is minus 0.68. I repeat, this calculated value is of t is 0.68. So if I try to correlate things, in our case, the estimated value of t is 0.68. Obviously, it would be minus 0.68. Yeah. So this is the t value. So when we are running a correlation coefficient, we are calculating, we do not know what is the position. Only when we calculate the value of t, we get to know what is the position. And as we have calculated the value of r and corresponding t, we will be comparing. So there are some critical values. Critical values are well known. These are t distribution are well known distribution, f distribution, chi distribution, all are well known distribution. So they are critical values. Critical values means values which are differentiating between acceptance and rejection region. Normally, let's say for argument's sake, put it minus 1.96 and here plus 1.96. I'm giving you extreme situations, but this is good enough for the discussions right now. So I know critical values are known. So we will check whether the 0.68 minus 0.68 value is between minus 0.96 and plus minus 1.96, or it is on the rejection region. Any one of you? Minus 0.68 is falling in the acceptance region or rejection region?
Acceptance, sir.
Acceptance region. So just because what is happening, that we are calculating with the help of software the value of r corresponding t, and t value can be compared on a distribution like this, and we can decide, we are not going to do this manually. We have direct results we'll be using, but one time I'm explaining to you so that you know the theory, but once, that's it. So right now I'm finding that the value of r or corresponding t is between the acceptance region. So I'll say that null should be accepted. So what is a null? That correlation coefficient is statistically 0, should be accepted. Are you with me? So this result says that the correlation coefficient between age and height is mathematically 0.24, perfect. But statistically, the value of t is 0.68, which is falling in the acceptance region. So the testing of hypothesis interpretation says that although the value of r is mathematically minus 0.24, but statistically that can be considered as 0. Means the association between age and height can be statistically considered as 0. So this is the interpretation or the purpose of using t. But we are not going to do this whole thing all the time. I'm giving you a shortcut. We calculate something known as p value. P value. And the rule says, if I try to explain to you, look at here. Look at here. Suppose it is right now, it is falling here. I can draw one more distribution. It is only on the corresponding t scale, and we have just seen that the estimated value of t is equal to minus 0.68. Let's, for argument's sake, it falls here. So this is closer to minus infinity. These are asymptotic distributions. The distribution, t distribution is asymptotic, meeting in the minus infinity and meeting in the plus infinity. So if I look at the area covered, so this t is closer to minus side. So my argument for p value will from minus infinity. Had this t been here, I would have taken the argument from plus infinity. So right now, just because it is on the left side, so I'm taking the argument from minus infinity. So anyone can tell me what is the possible area? This possible area between this curve to this, from minus infinity to this, If you take the analogy, so this is 0.25%, and up to this, from minus infinity to this, it is 50%. So obviously, this value will be how much? Any guess? It will be less than 50%, but more than 2.5%. Yes or no? Yes or
Yes.
no?
Yes.
So
Yes,
let's say
sir.
for argument's sake, this area is, let's say, 40%, 30%, 30%. 30% is more than 2.5%. So minus infinity to this is 30%. If I multiply it by 2, it is coming out to be 60%. Or if I convert that into decimal, 0.60. Right? So this is a rough idea that what is p-value. This is the p-value in this case. So if I look at the actual p-value, which will be very close to something like that, I've just taken a random value. Look at this. This 0.5130 is nothing but the p-value. Are you understanding these three? When I selected three options, when I went for correlation analysis using e-views, I selected three things. Correlation coefficient, I've explained. This is t-value for this correlation coefficient, and then this is p-value. So as I was explaining, this is the p-value. So my argument to estimate p-value is from minus infinity because my t is minus, so less than this part, so I have to take the argument. And from minus infinity to this point, I'm saying, let's say this is 30% multiplied by 2, whatever comes, convert that. So practically, I mean, just because I've randomly taken the value. So actual value, as I'm finding it here, this is 0.51 or 51.30%. So p-value does not show sign and all. Either ways, it have to just give you the idea that how much is the percentage or the area covered. So p-value absolute gives you absolute area. It doesn't talk about minus or plus. It is not important. What is important? P-value. Now I'm giving you final words for the interpretation. All the long story is very short. Just one liner. P-value. If p-value is if p-value is if p-value is less than or equal to 0.05, we interpret reject the null. Please pay attention to this. Only you need to cram. You always remember whenever we are doing any testing of hypothesis. We look at straight away p-value. If it is less than 0.05, look at here. What do you mean by less than 0.05? Let's say for argument's sake, my value would have fallen here. So if my value would have fallen here, so in that case, if you look at the area covered, just because up to this is minus 2.5 or 2.5%, from minus infinity to this point is 2.5%, so this will be less than 2.5%. Let's say for argument's sake, this is 1.5% into 2, this is 3%, you convert that, this is 0.03. So 0.03 is less than 0.05. So it means whenever the estimated value falls in the rejection region, p-value will be less than 0.05. So if I just explain to you, if p-value is in the rejection region, then null to be rejected. If p-value is in the, or the estimated p-value is the interpretation, or is the value which helps you to decide whether the estimated t-value is falling in the acceptance region or rejection region. So now we are finally giving you final words. If p-value is less than 0.05, it means the estimated t-value is falling in the rejection region and null to be rejected. On the other hand, when we find that p-value is more than 0.05, as the case in our example, the estimated p-value, we have found that it is 0.51. So what is as we have seen that t is falling in the acceptance region, and we are finding that corresponding p-value is 0.51. So if I use this benchmark, I'll say p-value is not less than 0.05, rather it is more than 0.05. So exactly opposite of this is going to be true. So we cannot reject the null hypothesis, rather we have to accept the null. So this is going to be the criteria. We'll straight away, whenever we are doing any testing of significance, we'll be looking at the p-value. If p-value is less than 0.05, we will reject the null, otherwise we'll accept the null. So in this example, very long story, coming to a one-liner explanation, we have run the correlation coefficient. We have got this correlation matrix. I'm looking at the correlation between age and HT. This is the first value is, I'm giving you clean screen. So the final values, if I look at here, I have got the value of 0.24 minus, I've got the t value, which is minus 0.68 or yeah, minus 0.68, minus 0.68, and my p value is equal to 0.51. So using this, I'll say that null of r is equal to 0 is to be accepted. And the alternate of r is not equal to 0 is rejected. So I'm using this. So I'll say that null of no association is accepted. So my interpretation is the correlation between r between what was the variable height and age. Height and age, though it is minus 0.24, but not statistically significant. Finish. This is the end of it. Now I'm open to question. If you are not clear, please ask question. Because I will not explain this much again and again. I'll straight away come to I'll look at the p-value and I'll make my interpretation. I'll move on. I'll not waste my time in discussion. The amount of discussion which I have just done, it is once, that's it, once for all. Feel free if you're not clear, any one of you, I have no problem explaining the whole thing again. But once the session is over and you still have problem, then you have to meet me offline. Feel free. Done. So we are back with this. So let me put the value. So as a style of writing, my height and age here, I'm just putting the value minus 0.24. And if you look at this, ready-made template ready, significant at 5%. Had the value of corresponding t value of this correlation less than would have given the p value less than 0.05, I would have put one asterisk here so that it signifies that the correlation between height and age is significant, means meaningful. Significant means non-zero or meaningful. So right now, just because the p-value in this case is giving me p-value of 0.51, which is more than 0.05. So the null of r is equal to 0 is accepted. So I can't say that the statistical correlation between age and height is significant, so I'll not be putting asterisk. I'll show you the other example. Look at this. The association between weight and height. What do you find?
Sir,
Yeah.
so basically we always when we have data variables, we try to find the null association of rejecting that whether it is whether it is related or not, whether they have a correlation or not. And if
I
it
will
is
give you.
rejected,
I'll suggest to you that always understand the null, because there are so many cases where if I try to generalize, it will be complicated. This generalization is perfect that p value, if p value is less than 0.05, null is to be rejected. This you cram. This is a general statement, generic statement. You can keep it with you. But
yes,
whenever
yes,
you are doing any type, let me complete. Whenever you are doing any type of study, you ensure that what is the null? Null varies. It is not that you have got one particular situation and r is equal to 0 is the uh, generalistic null. No, it's not like that. We have got, first of all, two types of null, and within two types you will find so many varieties. So it is always recommended that whenever you are doing any type of testing of hypothesis, you start with the null. Second, look at the p-value, and then you take a call whether to accept the null or to reject the null. I have told my point. You can, have the follow-up thing. Shivardhan.
yes sir. So we start with null equals to 0.
No,
We
no,
find that
again,
with
no. Listen. Correlation coefficient takes null r is equal to 0. Correlation. When I'm
yes
studying
sir.
something else, I'll give you different null. There is no general
Yes
null.
sir.
Type of null is
Yes.
generalistic too. No difference or no association. But correlation takes null of R is equal to 0. Something else will take null of something else. I don't know. As the case may be, I'll be having my null. But every hypothesis testing will start with a particular type of null. That is for sure.
Okay, sir. Okay. Uh,
Just wait. Gradually, as we move on, you will find every time we have a null and testing of hypothesis. Don't you worry. You can again ask me question. When you have more data set, you will be having a better question, right? We have just done once. Let me finish two, three
yes,
more.
sir.
And you will have more questions. You're most welcome. I have no problem to answer you. Right? May I? May I proceed?
Sir,
Yeah.
in this case, the null is accepted, right?
Null is accepted. What is null? R is equal to 0.
R is equal to 0. So that means the correlation can be said as it is 0. So it can be assumed to be
The
0.
language which we use, mathematically, it is minus 0.24. Mathematically, it has to be between minus 1 to plus 1. But
Yeah.
statistically, this is insignificant. What is the term which we use here? Insignificant means statistically it is not good enough that it can be further used.
Okay,
Or
so
it
we
can,
can say that it can be 0. So it can be termed as 0.
it can be
Can be assumed to be
statistically
0. Yeah.
insignificant is the right term. It means
Okay.
statistically it is 0. So if I have to use this result anywhere, I'll say that no, I cannot use because the correlation between height and age is insignificant.
Okay.
Mathematically, it is there. But
Yeah.
statistically, it is insignificant. So, as a statistical learning person, when we are using model for practical purpose, I'll say I cannot use it because the association is not significant. So, I'm stuck.
Okay, sir. Thanks.
So, coming back to my discussion between weight and height, look at weight and height. Same style of analysis. What is the correlation coefficient value here between weight and height? Class, what is the value of correlation coefficient?
0.7988.
0.79. If I round it off, it comes 0.80. So I'll write it down when I'm writing my table. The value between weight and height and weight I can use here. So I'll say 0.80, and it is plus, so no problem. What is the t value? 3.75. Yes. What is the corresponding t value? 3.75.
Yes, sir.
Yes.
Look at my discussion. I told you, rule of thumb. Rule of thumb is that critical values are minus 0.1.96 plus. Rule of thumb. Because case varies when we have a perfect science. So I'm not complicating things right now. I'm making it simple. So just look at minus 2 plus 2 something. If it is less than, so, just by looking at that, you can say. But again, you have to confirm with the help of p-value. P-value is a perfect estimate. So, just because you are finding that T is plus 3.75, which is more than 1.96, straight away you can have the idea that P value will be less than 0.05. And this is what exactly we are finding. P value is 0.0056, which is less than 0.05 or less than 5%. If I say this is how much? 0.56, which is less than 1%. Or this is okay to compare 0.05, which is 5%. So anything less than 0.05 means P value is less than 0.05 or null is to be rejected. And what is the null? Null is, this is rejected, so it is accepted. So now I can say that the claim of correlation coefficient is 0 is rejected. I will say that this value which I am calculating is significant because p value is less than 0.05. So I'll put one asterisk. I'll say that height and weight having correlation coefficient which is 0.80. First check, it should be between minus 1 and plus 1, which is there. Second, it is statistically significant. Why? Because p value is coming out to be less than 0.05. Done?
Yes, sir.
Height
Yes, sir.
and age. Let me put it there so that these values are one. High weight and weight, it has to be 100%. 100% means correlation coefficient will be perfect 1. So diagonal values are 1. All will be significant. Nobody reports it. Just we write 1. I mean, we are not putting significance here. I can put it technically, but that's not desired because anything between same variable will be 100%. So this value, let me get the third value between age and weight. If I look at the output, age and weight, if you look at that, p-value is again 0.18, which is not less than 0.05. So though correlation coefficient is minus 0.45, minus 0.45, but is not significant. Why? Because p-value is 0.1889, which is not less than 0.05. So I'll say that null cannot be rejected, null has to be accepted. So I'm accepting the null because p-value is not less than 0.05. So instead of rejection, we'll say we cannot reject. We cannot reject means we have to accept the null. Null of r is equal to 0 is accepted. I hope the point is clear. So these I can just have some. It is not good to leave anything blank. Write something, maybe dash, so that the job is done, completed. So are we through with the descriptive statistics? Done. Good. So now we are. Let me quickly show how this can be done on Stata. I'll show to you how to enter. If you remember last time I said that one of the good ways to enter the data in Stata is use this import option. Go to Excel spreadsheet, click, go to browse, and wherever you have kept your file last time I just picked up, so it is there in the memory, fitness first. And just because I have kept the first row as or for field, so I'm selecting import first row as variable name. That's it. It will ask for overwriting. It is just check by putting some command. Some you are finding that these four variables are there, which is coming. I hope all of you are with me. Look at here, standard deviation and mean values are by default present by the time you go for summary statistics in Stata. So straight away when you are using Stata, copy mean and SD and put in your descriptive table straight away. Need not do much. Stata is slightly difficult in the beginning, but later on you will find that Stata helps you more. It's very easy practically as compared to eViews. eViews is more graphical interface. It also provides, Stata also provides, but it is more command based. So command-based things, usually those who are non-computer background find it difficult, at least in the beginning. But later on, you will find that it is not that complicated, rather it is much more easy when you pick up the initial, I mean, when you are through with the teething troubles, you will find that it's very easy. So next is, this table can be, this portion can be easily estimated using Stata. Coming to correlation, then the command you can note down PWCORR, pairwise correlation, a space, and you can have all the variables as it is. So weight, height, age, comma, and then you write down star so that the significant values are star 0.05. I'm giving 0.05, and then you write down significance. So whatever is written after comma, that is the supportive, so that you get to know immediately that the level of significance you are putting at 5%. When I say level of significance 5% means I am giving this limitation, rejection is in 5%. I could have increased this to 10%. I could have reduced this to 1%. So 1% and 10% are the extreme cases. 5% is the midway. So it is always recommended that unless until you are very clear with the situation, don't venture it with the 1% or 10%, go to the midway. So use 5%. Same thing we are applying it here. And as I enter, you will find that same table, what we have got in eViews is also available, same thing. The only good thing here, I'm able to have the significant correlation coefficient, which is highlighted with the help of a star. So between height and weight, this was 0.8 rounded off, which was significant is what we have done. So only one significant correlation coefficient, all the other two are insignificant. So likewise, you are finding it here in Stata, the same results are getting reported. So I'm through with my descriptive statistics. I have to start with my inferential or regression analysis. I hope the things are clear to everyone. I'm free to answer question. If you have any, if you do not have any call, I can move on. Right. Now we are starting with the real game. We have made the introduction with the data. Introductory data, introductory interaction with the data is available. We have descriptors ready. Now we'll go back to the case, and the case was we were trying to find out the association between weight and these two, height and age, so that we have got a model ready which can be used by people to tell if somebody is of certain age and of certain height, what is the weight which comes under the healthy bracket, healthy, what is the range of healthy weight. So that is the job which we are trying to do. We are trying to develop a model. Now look at this table 2. Let me come back and talk to you. What happened? We are discussing, this application of regression is practically present in almost all the areas of business. You will be having some or the other amount of discussion in courses like statistics, courses like your managerial economics, even in your marketing courses if people are going for demand forecasting. So there are so many occasions where you will be using regression analysis. But what we have found with my own experience teaching this course for more than 15, 17 years, that when it comes to really applying it, passing the exam is very easy job. But whenever you have been given a chance to really apply it, only 10, 20, or let's say 30% people practically find themselves able to use this. So this time I have tried to change the style of discussion, as well as I have started sharing the template. So I'm very intentionally sharing with you template so that you have something ready. So in any occasion, you are doing any type of regression analysis, this table is a complete table for presenting the output of regression analysis. This is a complete template. So you can fix it anywhere, whatever you have to add. Suppose you have got more than two, you just straight away go and insert one more row below it, and that's it. You can have three independent variable, four or whatever. You have one, then you knock out the one row, and your whole discussion is a whole template for presenting the output of regression analysis is ready. Why I'm talking about this, I want you guys to use regression analysis, which I found hardly 20-30% practically used. So I would encourage, you have got options to write a research paper. Probably if you are aware, I guess you have to write one paper. In addition to that, you will be going through many case studies in different competitions. There are so many occasions where you can use analytics, including regression analysis. So I would insist, develop the wisdom, and you should have the courage also, because you are having the help in the form of templates, and you can make use of them. And as and when you have a situation, I have found people avoid to use. So my discussion of this 5 minutes is just to encourage you, don't avoid. If you think that somewhere situation can be answered better with the help of regression analysis, use it, and be bold. Whenever you are doing something first time, obviously you will have some initial hurdles, but once you do it, you'll find that it will be very easy for you to do it second or third times. The regression is the basis of many advanced statistical analysis. So that's why you have to be very clear. And I believe this time my giving of template may be much more help. This is the initial discussion before I practically start using the data analysis and fill this table. Look at this table. So today I don't have that much time to complete, but some part of that I'll try to complete. So this table, as you are seeing, we'll be completing this table first, and then look at this discussion of output. Regression analysis of any type. I'm making a bold statement. This applies across the board. You are doing regression analysis of any type, between any type of data set. You will find that these 5 heads are more than enough to elaborate the discussion on regression analysis. If you are clear with these 5 heads, you can replicate, use this table, enter the data. Once this table is completed, use these 5 points to talk about the output, and you can discuss at length, and your information, your analysis will be ready to be used by you wherever you want. So I guess these two 5 points, they are also handy. We'll take up them one by one. So my first job will be to fulfill the complete the table. I have around 15 minutes time. Some part of it I'll try to finish today. All of you are with me? Do you have any question? We'll start with filling up this table too. Yeah, Shivardhan, please go ahead. Go ahead.
No, no, sir. I was just saying yes, we are with you.
Great, great, great. Anyone, I strongly encourage each one of you, please speak up. I appreciate when you raise questions, doubt, disturb me. I want to be disturbed when I'm talking. There's no monologue, not interested in telling what I think. You can regularly disturb me and ask questions. As many questions as possible. Feel free in asking. So I'll start with the e-views. Yeah, we are here. Let me close this. I've deleted the group. I've used the information, whatever I wanted from a descriptive. Now I'm moving towards regression. I'll go for quick. So this worksheet is already there. I've made in the beginning. I'm making use of that. Go for estimate equation. You can write down this command, I mean the position of this command. Go to quick and estimate equation. Click it here. This will come. The default setting is for regression. We have got many other methods. Right now, we are only making use of, as you are finding, least square. LS stands for least square. Full name is optimum least square. Some of you who are a little inquisitive, they can write down optimum least square. This is the method which we are using to do the regression across the world. Wherever you will find the initial regression analysis is discussed, it is discussed using OLS only. So regression analysis, whether it is simple regression or multiple regression, takes input from optimum least square method. So we also do the same thing. We use OLS, optimum least square or OLS. So now I have to enter. So whatever is my dependent variable. If you look at the case, we are talking about, we want to develop a model to relate the weight with respect to age and height. So weight is something which we are interested in knowing. Impact on weight of height and age. So just because we are interested in knowing the impact on weight, so weight becomes the dependent variable. I'll write down the whatever name of the variable I've given, weight as it is. And if you remember, we have discussed this several number of times that whenever I'm talking about analysis, regression analysis, I'll be presenting usually this way: beta 0 plus beta 1 x1 plus beta 2 x2, and I'm putting one cap so that I'll say that estimated values. So look at, whenever I'm running any regression model, I'll practically be calculating these coefficients. And that is the reason, if you look at the template of output, the first discussion is about correlation, I mean coefficient analysis. So first discussion of output is about the coefficient. When I say coefficient, I'm talking about these three things. Right now I've got two independent variables. I may have more, so accordingly I can add beta 3 x3, something like that. So I have to take a call that what is y and what is x, what is y and what is x. I have to take a call. So right now I know that y in my case is weight, and in our case, one x is height. There's no rule of put which to come first. Anything can come first, and age I'm putting as second. So this is the model which I'm trying to interpret, and with the help of regression analysis, I'll be practically calculating beta 0, beta 1, and beta 2. So coming back to e-views, so I have to, just because I have beta 0 also, so I have to give a command or one indication to e-views that I'm interested. So that is C. C is constant. Beta 0 is supposed to be the constant. And then both the variables in the given order is not important. I could have placed A's before ST, but let's follow this order. So H, T, and H, that's it. So let things be, all the other things should be default set. Just put the variables as per the model. There is no rule. Your model, you are going to test. Then go for OK, this output comes. In this output, if you look at the table, we have to fill the table. You have to fill the regression table. Look at this portion first. We'll be partly filling this portion. So let me put it, x1 is nothing but height, and x2 in our case right now is x2 is nothing but age. This is what we have. And right now, whenever we are going to estimate coefficient in any software, we will be having unstandardized. There are two types of coefficients, standardized and unstandardized. Next class, I'll elaborate the difference. Right now, the general statement, whenever you find output in any software, whether it is Excel, Stata, or eViews, the coefficient which you have straight away unstandardized. So let me put the values. Minus C, constant value is minus 39.09. So 39.09. So that is the value. Height, look at the height coefficient 0.73. 0.73, and then age coefficient is minus 0.26, minus 0.26. So if I just try to give you the idea, this is my estimated model. I'll write that weight is equal to just got value how much, 39.09. So I'll write down 39.09 plus the value of height is 0.73, so I'll write 0.73 height, and I'll put it here, plus minus is there, no issues, I'll put it that way. So this value is 0.26, so I'll write 0.26 into age. Now this is my estimated model. One part of the story is ready. I have to complete the table, then I'll be able to interpret this more effectively. Coming back to my table, I need to, this I'll discuss later, so that I'll give you the utility then. State value I can show you right away, but I'll discuss the utility, then I'll give you the value. Right now we are having something known as standard error. Look at here, we are having after coefficient standard error. A standard error is a estimate which helps to identify what is the amount of error which is present in estimating these coefficients. So I don't want to give you theory which is of no use for you. And if you are interested, meet me offline. Whatever you want, I can explain. But I'll keep the class discussion more focused on the utility side, so that you can use the learning for practical purpose. So I'll give you less theory, more of application. Keeping that in mind, the standard error is the estimate which tells what is the level of error which is present in estimating the coefficients. So straight away we can copy the values. Here I'll say constant, the value is 37.56. Height has got standard error of, I'll round it off to 2 decimal point, 0.21, and then age has got standard error of 0.20, I can round it off, 0.20. And what happened that T statistics, you can mathematically calculate, T statistics is, I can note down, I'm showing you two statistics is coefficient unstandardized, is because we have two, so I have to write it down, divided by SE. SE of that, suppose I say J, EJ, coefficient of J and T for J. J is nothing but the identification for which variable we are talking about. So the T for, let's say, height is equal to coefficient unstandardized, coefficient of height divided by corresponding standard error of height. As you can see, height 0.7320 divided by 0.20, you will find this value 0.351 is coming. You can check yourself. So we are having a value, what is the value? 0.7320, 0.7320 divided by, I'm having the standard error of 0.2083, 0.2083, and you are having the, I guess it is visible to all of you. So we are having a value. If you look at those, there would be some rounding off error, but t value is same. So what happened at times, I'll be discussing this issue, what to be reported, what not to be reported. But right now in my table, I have got t value also, but t value is something which can be derived provided I have coefficient and standard error. Right now, it may be Greek and Latin for you, no issues. Let the table be completed. Then I'll come to the discussion. Then you will find that each and every information which is provided in this table is of immense value when we are explaining the results of regression. So right now we are mechanically just filling the details. Let me complete this portion. I'll take 2 more minutes. So T statistics for C minus 1.04, minus 1.04. For HT, it is coming out to be 3.51, 3.51, and age is coming out to be 0.1. Start T is 1.34. That's good enough, minus 1.34. I've told you rule of thumb. Just by looking at that, you can find out that only this is having t value more than 2, 2 or minus 2. So only this seems to be significant. All the other t values are not significant. P value will have same rule. The only difference right now here is that in the case of coefficients, I repeat, in the cases of coefficient, the pair of hypothesis, I'm using null of no difference. I'll say that Bj, J is B, J may be 1 or 2. Independent variable, there are 2. So 1 for height, 2 for age. So general statement, the null is this, and alternate is, though you are finding I'm using 0, but don't get confused. Always be very specific with the null, definition of null. This is null for coefficient in regression analysis. This is general null. All the time we'll be having same null. Whenever we talk about any regression analysis, the general null hypothesis will be this. Coming back to my estimation p-value, I'll quickly take the value. These are probability which are nothing but p-values. There's again one rule of thumb that p-values will not be given to you on a platter, rather you have to figure out. But it is all the time there whenever you are having any statistical analysis. So gradually you will become used to finding out where the p-value is, though it is not written as p-value, but you will be able to find out. Don't you worry, this is not a matter of concern. It is easily available. So p-value in this case is 0.33. So 0.33. This is 0.0090098. And as a matter of practice, p-value we try to write up to 4 decimal point if it is available. So I'll put it 26. And then 0.2208, 0.2208. So here we go. We are ready with this part of the table interpretation. We'll understand next class. I'm keeping this output saved. This will be available to you also on the shared drive. Whatever discussion I have done on the OneNote, that will also be available, and we'll be adding more things as we move to the next class. And I've requested Karkarji to have one class every week so that we don't forget. Last class on 27th of August, and right now we are having a class after 15-20 days. So next week again we are going to meet. We'll continue with this. I believe things are clear. If you have any question, I can take up, or you can meet me offline also. Any question?
Sir, could you recommend some reference books for these?
Vanshita would have shared with you one book, Chris Brooks, I guess. Vanshita, have you?
Yes, sir. Yes, I've shared it on WhatsApp.
Use it.
Yes.
And I'll suggest that I'll share some material on the Google Classroom. Some focused material. You refer to that much material only, that would be good enough. Provided you are interested in studying things in slightly deep. Otherwise, whatever I'm discussing, they are more than enough for examination purpose. But yes, you want to study more, you can use book. But I'll give you some more focused material for you to study if you want. Yeah, I'll provide you. Akash, I'll provide you.
Sure, sir. Thank you.
Anything else? I'll try to give you some videos. Videos are more handy. So maybe my videos or somebody else's video, I'll provide you a link to more relevant focused videos so that you don't waste time and you get more input. That's it. So, okay, guys, we'll meet next week again. Thank you very much.
Thank you, sir.
Thank you, sir.